In order to complete problem 15 from task number 9, you're going to have to rely upon what you learned in Algebra 1-2. And so in Algebra 1-2, we learned that when the first difference is the same, it's linear. When the second difference is the same, it's quadratic. And when the third difference is the same, it's cubic. So let's first figure that out. So I'm going to go ahead here and notice that as we go in this direction, the numbers here are going up. So negative 49 is more to the left on the real number line than negative 15. So I can go ahead here and I'm just going to do a simple subtraction here. So we're going up 34. So this is a plus 34. Now I need to be neat here. This is a plus 10. Now I went back down 2, and now I went back down 2 more, and then I went, well, the difference from negative 9 all the way up to a positive 1 is a plus 10. Those values, when I compare, and by the way, in order for you to do this, these have to be equal intervals. These have to be equal intervals for x values in order for you to compare the y values of a function. So when I compare, none of this is the same. So I know the first difference is out. The first difference is out. So it's definitely not going to be linear. Let's try the second difference. So here I went down because positive 34 to positive 10 is I went down. How much? I went down 24. And then here I'm at positive 10, but then I dropped down to negative 2. So think of this on a number line. You're at positive 10, but then you go all the way down to negative 2. So you dropped down 12. Okay, then I stayed the same, and then I went from negative 2 all the way up to a positive 12. Oh my goodness. And you could use a calculator in order to do this as well. So second difference is not the same. That means these points do not reflect a quadratic function or degree 2. Okay, here we go. Now from negative 24, so negative 24 is somewhere way over here, right? It goes from negative 24 up to negative 12. So I increased by 12, so I went up by 12, then I went up by 12 again, then I went up by 12 again. Notice how the third difference is all the same? That means this is going to reflect a cubic function. Grab your graphing calculator, please, and do second plus 7, 1, 2. Let's clear the RAM. And now we're going to use a cubic regression model in order to find an equation that is going to take these points. So let's go up here and hit Stat, and Edit is already there. We're going to press Enter. L1 is going to be your x value, so negative 2, negative 1. And we're going to go back and do the same for the corresponding y values. Negative 49. It's really easy to make small mistakes when you're going through this, so don't rush the process. I'm actually going to go back and make sure everything looks good. Okay, now once everything's plugged in, we're going to hit Stat, and we're going to go to Calculate and find the cubic regression. You're going to press Enter all the way through to the very end, and this is representing your equation. So if they ask for an equation, we could write y equals 2x cubed minus 6x squared plus 2x minus 5. That works. That absolutely works. And now when we want to figure out what is P of 5, you're simply going to plug 5 in here. So you have a couple different ways you can do it. I find this the easiest. I want to copy this into the function. That's one way to do it. So we're going to come up here, and to copy this in, like copying and pasting, after you hit y equals, I want you to find the button that says bars, and then go down to Stats. Now go to Equation and press Enter. That's your copy and paste. Now when we look at this graph, we want to know when x is 5, what is the corresponding y value. So it's graphing it right now. Here we go. Second, trace, do this again, second, trace, find the value when x is 5, and the y value is 105. You do also want to write it in this form, okay? This would also be equivalent, but this is really what we're looking for, especially when you see how the question is asked.